Okay, so this is lesson 8, apply the Pythagorean theorem. This is probably one of my favorite types of math, where you're actually taking a formula and applying it to like a real world situation. I was actually at my aunt and uncle's house a while ago, a couple years ago, and my uncle was building either like a bocce court or like a horseshoe pit. I can't remember what he was doing, but he was building this frame, this rectangular frame, really long rectangular frame to put in their yard in order to play some kind of game. So he was like building this frame like this out of wood, and he wanted to make a perfect right angle here. And so I was sitting there just watching what he was doing and sipping on my coffee, and he's like, hey, what's that formula for finding like the perfect right triangle? Like, what do I have to measure one length to the other to find like the distance between these two? And I was like, oh, a squared plus b squared equals c squared. And so he's like, how did you remember that? I'm like, well, I teach it in math. And so what a lot of kids forget is that these formulas and these things that we learn in math are actually for everyday use. Now, we may not use them all the time just in like living our lives, but when you're building things or measuring things or engineering things, you do use these formulas. They are like, we do have them for a real reason, not to just do math in school and not just to like develop our brain. So this is kind of my favorite part of math, is we're actually using things that we've learned to figure out real world situations. The Pythagorean theorem can be applied to real life problems that contain right triangles. The distance formula can be used when real life problems use points on a coordinate grid. So our example 1, Brian uses a 15-foot ladder to paint a windowsill that is 12 feet above the ground. How far from the base of the wall should Brian place the base of the ladder so that the top of the ladder is 12 feet above the ground? Use the Pythagorean theorem. The wall and the ground form a right triangle. So the wall and the ground and the ladder form a right triangle. The ladder represents the hypotenuse. It measures 15 feet. The wall represents one of the legs. It measures 12 feet. We do not know the distance from the wall to the ladder. That's what we need to figure out. And so like if he didn't do this, if he didn't figure this out, now he can just kind of eyeball it and keep pushing it back or pushing it forward until he gets here. But he wants to measure it exactly so he's exactly where he needs to be when he gets up here. So like if you place the ladder here, then the slope would be steeper and the ladder would be farther up the wall, and he wouldn't be at where the window is, right? Or if you place the ladder farther back, the slope would be more shallow and he wouldn't be high enough to reach the window. So he's going to use the Pythagorean theorem to figure this out. He's going to say this is what we don't know. So this is A, B, and C. A squared plus B squared equals C squared. So we plug those numbers in and we're going to say that this is X because this is the unknown number. You can keep it as A too, it doesn't matter. It's a variable, so you're going to be able to figure it out anyways. So X squared plus 12 squared equals 15 squared. X squared plus 144 equals 255, which is the square of 12 and 15. Subtract this 144 from both sides to get 81. So X squared equals 81. So the square root, so X equals the square root of 81. So X equals 9. Brian should place the ladder 9 feet away from the wall. Helen is building a patio. She measures the diagonal distance to see if the corner of the patio is perfect right angle. Determine if the corner is a right angle. This is what we want to do here. Use the conversion of the Pythagorean theorem, and that just means we're just checking to see if it fits, right? So we're going to say that this is A, this is B, and this is C. So 14 squared plus 17 squared, we're trying to find out if that does equal 21 feet or 21 squared. So 196 plus 2 89 equals 485, and the square of 21 is 441. So this right here is not a perfect right angle. Helen screwed up, which, and it's not that big of a deal if it's not a perfect right angle, but if you want everything symmetrical, it's smart to do this. All right, a carpenter has boards measuring 5 feet, 6 feet, and 8 feet, and 10 feet. Is it possible to form a right triangle using 3 of the boards? So basically, you can do 5, 6, and 8, 5, 6, and 10, 5, 8, and 10, or 6, 8, and 10 to build this right triangle, right? Or to build a right angle. So to figure this out, I don't see any of them being perfect squares or the Pythagorean triples, but to figure this out, let's go ahead and try it. So 5 squared equals 25, 6 squared equals 36. Does that equal 64? No, it does not. So this is 5, 6, and 8. So that combination doesn't work. Let's try 5, 8, and 10. So 25 plus 64 equals 100. No, it does not. So this is 5, 8, and 10. And then the last combination with 5 would be 5, 6, 10. So 5, 6, 10. So that's 25 plus 36. Does that equal 100? No, it does not. So nothing with 5 works in it. 6, 8, and 10 is our only other combination, right? So 6 is 36 plus 64. Does that equal 100? Yes, it does. So 6, 8, and 10 works. All right. So we can use those 3 boards to make his triangle. All right, what else do we have? Chris rows diagonally across a river towards the dock. The width of the river is 18 meters. So this is the width of the river. Chris starts rowing from a point 30 meters downriver from the dock. So this is where he starts. This is where he wants to end. How far does Chris row to the nearest tenth of a meter? Identify a right triangle. Use a Pythagorean theorem. Find the right triangle. The width of the river is perpendicular to the bank. This diagram shows the right triangle with legs measuring 30 and 18, or 18 and 30. Chris's path represents the hypotenuse of the triangle. Apply the Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. And then so we have 18 squared plus 30 squared equals the unknown, x squared. So 18 squared is 324 and 30 squared is 900. So 324 plus 900 equals 1,224. Or x squared equals this. So x equals the square root of 1,224. And then I'm just going to use my calculator to find that. And it's this number, so we round to the nearest tenth, which is right here. And because that is 8, this goes up 1/10, which turns us into 35. So he rows 35 meters across the river. All right, how do you determine if an angle is a right angle when the lengths of all 3 sides of a triangle are known? You use the Pythagorean theorem. A squared plus b squared equals c squared, the converse. So you're trying to prove it. A rectangular television set measures 30 inches diagonally across and 24 inches wide. What is the height of the television? So this is 24. We're trying to figure this out. So it is 30 squared equals 24 squared plus the unknown h squared. You can use that. So 24 times 24 equals 576 plus h squared. 30 squared is 900. So the difference, 576. So h squared equals 324. So h equals the square root of 324, which equals 18. So h equals 18 inches. All right, and so then you can use the Pythagorean theorem to finish these up. Again, I love these word problems. And all you're doing is using that a squared plus b squared equals c squared to figure all this stuff out. Let me know if you have any questions over Google Chat or email, and I will help you with those. And then also, I'll email you guys, but let me know when you want to meet for your Zoom.